Hello, good day. Welcome to our channel where every seemingly difficult problem is solved using very simple, easy, fast and accurate steps. So we have this problem. This is WAS from 2022. An electric heater you use to supply a current of 12 amperes for 1,400 seconds to a body of mass 1.5 kg at its melting point. The body melts and its temperature rises by 60 degrees Celsius in an extra 1.2 minutes. Calculate the latent heat of fusion of body, specific heat capacity of the body. Good. So the first thing I need to do is to say heat loss is equal to heat gained. Now, who is losing the heat? It is the heater. And then who is gaining? So if we define our parameters, we have that I is equal to 12 ampere, our V is 40 volts, our time is 1,400 seconds. Then what else? I will give in mass to be 1.5 kg. So, and I'm looking for L. So the statement here will be I V T is equal to ML. So if I make L the subject of formula, because this is what I'm looking for, this becomes IVT over mass. And our mass here, and our mass is 1.5. 1.5. So I have 12 times 40 times 1,400 all over 1.5, which is 3 over 2, which is the same thing as, I don't want to use my calculator. So I have this 4. So I have this times this, which will give me 28. Okay, let's do this times this is 56. 56 times 8. This times this will give me 56. I have 3 zeros already. 1, 2, 3. So 56 times 8 will give me 8 carry 4. So I have, this is what I have. My answer is equal to 4.48 times 10 raised to power 1, 2, 3, 4, 5. 10 raised to power 5. The unit will be joules. Energy is in joules and mass is kg. So this is joules per kg. I'm done solving that problem. Now the second question is at melting point, because when we talk about melting point, there is no change in temperature. There is no change, but there's a change in state. Even for ice, using ice as an example, ice block. When the ice changes from, when the ice block changes to liquid, 0 degrees Celsius, 0 degrees Celsius at solid, 0 degrees Celsius at liquid. So that's the reason for the word latent. Latent means hidden heat. Now we are done with that. Then we are told the second statement is the second sentence, the body melts and its temperature rises by this. So if we assume that the melting point, let's say it is 0 like water, this is what we have. 0 degrees Celsius, then it rises by 60 degrees Celsius. You can see there's a change. So this is our ML, and here this is MC theta. So in this case now, we are told in an extra 1.2 minutes. So we know that we have to change the minutes to make sure that it has the same unit as seconds. That's the unit of time. So this is 60 seconds is equal to 1 minute. Therefore, 1.2 minutes is equal to what? That's 72 seconds. So because they say an extra means additional 72 seconds, we had an increase in a rise in temperature of 60. So we know that our time now will no longer be 1,400 seconds. It will now be 1,472 seconds. That will be our new time in order for us to calculate the specific heat capacity of this body. So the next statement now will no longer be this. It will now be, we have heat loss is equal to heat gain. That's always your first statement. Heat loss is equal to heat gain. The next thing will be IVT is equal to ML plus MC theta. Where is our theta now? Is final temperature minus initial temperature, and the final temperature is 60 minus 0, which is still giving us 60 degrees Celsius. So coming back here now, this is what we are asked to look for. We make C the subject of formula. It becomes IVT minus ML all over M theta, which will be we have something like this. We are saying 112 times 40 times 1472 minus 1.5 times 44800. Yes, that's 3 zeros. Good. All over our mass is still 1.5 times what? Times 60. So we are saying here, let's see if our calculator will work. If it doesn't work, okay, so we have 12 times 40 times 1472. Yes, so we have 706,560 minus 1.5 times 44800. So we have 672. My God. Okay. If I do this 3 over 2, it's 224. So I have, I don't know what's wrong with my calculator. So what will happen is this: you just have to do all of this divided by, this should be 75. Do all of this divided by this and give us, okay, we have our calculator is back, it's using solar. So we say, let's go back, we say 1.5 times 448,000. Yes, so I have 706,560 minus answer divided by 75. So our answer is 4608. Since it is specific heat capacity, this is joule per kg per Kelvin. Yes, that's our unit. So either you write this or you say 4.60 times 10 raised to power 3 joule per kg per Kelvin. That's our answer. Please do well to like and share this video. God bless you and bye.